Ladies and gentlemen, it is now, as mentioned, time to introduce our first two speakers today. And I am pleased to introduce to you, I'm just going to move on over here to where we will be having our interviews. I'm pleased to introduce to you our first speakers and a long-established team. Now, here come two companies, ladies and gentlemen, whose cooperation is of tremendous value to many of you. The combination of Claas and Dassault Systèmes stands for innovation and professional know-how in each of their businesses. And the title of this very first keynote is Systems Engineering Solution Lab, Experience Model-Based Systems Engineering at Claas. And now, to set the mood just right before I bring out our first speaker who is here live with us in the studio, I would like to introduce to you a short film. Roll the film, please. And what an introduction it was. And we now have with us, and I'm very pleased to welcome Global Account Director of VW at Dassault Systèmes Germany, Maik Felten. Thank you so much for joining us today, Maik.
Thank you for having me.
It's wonderful that you could make it out, even in person, from a distance, but of course, all the more warmly, as we like to say. Now, Maik, we did get a short teaser, a short introduction film, but we will be seeing the keynote, which is with your partner from Claas. Maybe you can give us just a little teaser of what's about to be shown?
First of all, on behalf of the full Dassault Systèmes team, a very warm welcome also from my side. Good morning. I'm very honored to be presenting together with Claas. Unfortunately, Dr. Kai Korthals can't make it into here. Claas will be showing us a glimpse of what they did with us the last 4 or 5 years already, digging deep in the topic of systems engineering. And currently, a lot of companies are looking up to Claas, what they've achieved already, and how they are about to transform their entire business with systems engineering.
You have made us even more curious, and I think it's time to bring out your partner. I was going to say partner in crime, but that may give us a wrong impression. Just only your partner for the keynote, for the video coming up. Ladies and gentlemen, I would now like to welcome our next guest, our second speaker from Claas. This is Dr. Kai Korthals. He is head of Digital Product Engineering Department. He has been driving systems engineering for several years now, and he set up the Systems Engineering Solution Lab, which acts as an incubator for systems engineering solutions within the Claas group. Together with his systems lifecycle management team, he deploys requirements engineering and systems thinking within the enterprise, and I hope that he will be able to join us virtually. And there we have Kai. Are you hearing us, Kai?
Yes, thanks. I'm hearing you quite well. Welcome from Hasewinkel.
Thank you for joining us. We already did get a short teaser from Maik over here, and of course, we would also like to know what Claas has to share with us, a teaser of the video we're about to see. The title, after all, does withhold the words experience model-based systems engineering at Claas. So what is it all about, Kai?
It's exactly what it says, meaning experience model-based systems engineering. Model-based systems engineering for many persons, especially model-based, is a very abstract matter. So we'd like to bring it to the people, to experience what model-based system could look like and make it tangible. And that's the core of our systems engineering solution lab.
Simply because we do have just a couple minutes left, gentlemen, if I may ask you just one or two more questions. Starting off, I did describe your work together and your collaboration as a cooperation of tremendous value. How would you describe your long-established teamwork? Maybe I'll start off with you, Maik.
How would I describe this long-established
Yes,
teamwork?
your partnership.
I think we're partners in crime, like you described.
Really?
Partners in sharing the same vision, sharing the same values, and like to bring things forward, not discussing and doing theoretical work all the time, like many are still doing and planning ahead. Claas is a partner in crime to really set something up and act.
Mm-hmm. And Kai, what would you say, why is your cooperation of so tremendous value?
Yeah, I fully agree to Maik. Maybe I can add the point that is a very trustful partnership, and it's a partnership that begins not about negotiations and discussing about licenses. So that is something that I really appreciate. So we have really a standing team for over for over 4 or 5 years. Where we easily can collaborate with without having any contracts or something like that. So we really stick together if we think there's a topic or there's a vision, and then we meet and try to push topics forward. And that is something really beyond the normal license management and contracting, and that is something I really appreciate with the Dassault colleagues.
Now, Kai just mentioned something very interesting, that you basically cut right to the chase, you get right to work without getting caught up with all the bureaucracy that we're used to, especially here in Germany. Maik, would you say this is something that maybe colleagues or partners could sort of take over for the future? Less bureaucracy and more
Absolutely.
Innovation.
Yeah. Innovation is key and speed is key, obviously. But it comes with both sides, right? So it can't be a one-side direction with less bureaucracies. Huge customers do have bureaucracies as well.
Of course.
So, and with Claas in the German Mittelstand, this is a kind of spirit which is really startup character, especially when I look into the greenhouse, where they invented this kind of mentality, I would say. This is really something to look at, yeah.
And I feel like you guys really do have ants in your pants. What comes next? Can you give us maybe just a short teaser of the future between Claas and Dassault Systèmes? What can we expect in the near future, perhaps, Kai?
In the near future, yeah, of course, we're also discussing a lot about digital twins, Maik. I think it was just yesterday night.
Really?
Very late now. So, of course, we're also discussing about digital twin and thinking about how we can push this topic forward within Claas. And that's what I mean with we're having a very strategic and deep collaboration. So we are really thinking ahead and thinking, okay, what does this mean for Claas? What can be the share of Dassault in this topic? And what can be or the contribution before talking about any licenses and software solutions. And so I think this could be also a topic to be presented here in a few years.
In a few years, okay, we'll give you 2, but we look forward to that in 2022. What's your vision for the future, Maik?
Execution, speed.
Again, just getting right to it.
Yeah.
Okay. You know what? We're going to stick to that attitude and get right to it, gentlemen. Maik, Kai, thank you so much. I think we'll just jump right into your film. And ladies and gentlemen, please do keep in mind that you can ask questions at any time. Please use the chat function. You should find that on the right side of your screen. Feel free to type in any question at any time, and we will get back to that with Maik and Kai live, partially in the studio, partially digitally at the end of the following video. But with all of this said, I think we can now roll the film. What do you say, Maik? Should we do it?
We can, yeah.
All right, then, director, please roll the film.
welcome at the Claas greenhouse. So we have chosen this place because this is exactly the point where we started our common journey in the field of systems engineering. Within this building, we developed first concept and solutions for the systems engineering topic. Right now, we are in a pilot phase in the productive environment, but I would like to discuss that with Dr. Kai Korthals, which is over there. So let's go to him. Hi, Kai.
Hi, Mike. Welcome at Claas Greenhouse. Great to have you here again.
Yeah, thank you. So Kai just said that we started our common journey in the field of systems engineering at this very place. So this is almost 2 years ago, and we have developed so many things. But before we come to that, what do you think about pitching Claas first?
Yeah, that's a good idea. Claas is a leading equipment manufacturer for agricultural machinery, but of course not every person is familiar with this environment. So I've provided here some of our products to give you an idea what we're handling with in our daily business. So you see here our combine harvester to harvest wheat on the field, and here next to it the forage harvester, for instance, to have corn for the biogas plants or for the silage. In our portfolio you will also find our tractors, and on the right hand side we have the forage equipment like balers, rakes, to provide premium and professional solutions for our farmers.
All right, thank you very much. But this leads to a question, systems engineering and farming industry, how does that fit together?
Mike, that's a very easy answer. Okay. So have a look to our combine harvester. This is a plant on reels. So it's highly automated and complex processes that are running within this machine. Yep. And the guy that knows everything, the wise guy, is gone. He's no longer existing. So we need to orchestrate and to structure our engineering work in a far different way than we did it 20 years ago. Yep. And on top of that, our machines nowadays are really connected on the field and driving autonomously. So we are far beyond simple mechanical engineering. So we need to combine electric solutions and software solutions with our mechanical solutions to develop such high sophisticated products. Another driver comes from the intern. So our engineers are complaining about too many methods and too many tools. So they are requesting a more holistic approach. And so for us, systems engineering is a dominant strategy to give answers to all these questions.
I see. Okay. So what do you think that you show us what we have achieved together in the last 2 years?
Yeah, that's a good idea. So come on, follow me. Some of the already mentioned and further driver for product engineering are shown here on the slide. To sum up, product complexity has increased steadily during the last years, and we need to find an answer for that. So in the end, we need efficient and effective collaboration on both sides, on organizational side, but also on technical, meaning on assembly group and functional side. Complexity is given, no doubt about that, but we need to make it transparent and manageable. To give answers to that, we have 2 parallel approaches here at Claas. On the one hand, the engineering system, and on the other, the already mentioned model-based systems engineering. So what is the engineering system? It's not only the IT system as you could assume. It's a more holistic approach. It contains processes, methods, data models, yes, applications, and also IT infrastructure. But in the end, it's an holistic platform that provides knowledge along the entire product development process, role-specific and job-specific. Next to it, we have the systems engineering approach. Like many other modern companies, we at Claas also have a product development process that defines the what is to be done in what sequence. We are also very highly sophisticated in the area of domain-specific engineering, like mechanical engineering, software engineering, hydraulical engineering. But oftentimes, the connector between the process level and the daily engineering work is missing. So here, our dominant strategy is systems engineering to define the how and with what. Roughly 2 years ago, we decided to establish a systems engineering solution lab to being disruptive and to really create tangible benefits. In the end, we want to define how we want to engineer products here at Claas in the year 2025. Our goal was to give both a proof on the systems engineering methodology and the IT system next to it. To give you an insight, I'd like to show you one use case here. So the optimized chopping quality, according to the utilization purpose, for instance, like in a biogas plant or in a silage, according to the very variable quality. So our machine needs to be capable to handle that and to provide always the best optimized chopping quality. I'd like to take you on a journey, and on our journey we will meet the product manager, the system engineer, and the validation engineer to show you how our Claas engineering system and the model-based systems engineering look like.
As a product manager, I represent the customer's needs towards the Claas engineering team. The farmers expect a high crop processing quality to allow the cattle to draw as much energy as possible from the crop. However, the conditions the crop is harvested are volatile. To optimize the customer benefit, I expect the forage harvester to deliver continuous crop processing quality even under changing conditions. The Claas requirements engineering framework helps me to get that. The methodology supports me to specify unambiguous and complete requirements. I also have my personal working space, the product layer, where I'm responsible as the product manager. Here I document my requirements. The tool creates transparency along the whole team regarding the requirements, even in early stages of the development. It guides us through the review process and the alignment of the requirements. This saves me overhead communication and additional calls and mails. The traceability among the requirements also gives me feedback from my sparring partner, the system engineer. How he's going to realize the requirements. It also shows me which requirements are not addressed yet.
As a system engineer, I take the requirements of the product manager and bring them into design. As a consequence, my data that I'm using is found here on the machine layer and on the system layer. And I take, of course, the requirements from the product manager. I open the requirement specifications, analyze it, and search for the relevant information that is needed for me to implement and build up the needed functions and components to realize the functionality that is found or that is searched from the product manager. Of course, finally you can see the physical development data here in the system as well. Every time during the process you can see which requirement is covered by which functionality. So we can see here with a trace link what has been done and what has been realized, how it has been realized. My international team always notes in which task or on which task we are working and which tasks are so far finished.
As a test engineer, I have here all my relevant data in one view. The requirement specification, the test specification, and also my overall validation plan. Based on the requirements, I can specify my test cases. And at the end, I have a full traceability between the requirement specification, my test case specification, and also my test results, where I can create reports based on these results.
Finally, all information for the product engineering are stored in our engineering system, structured according our systems engineering layer. I hope you enjoyed the journey through our engineering system and the model-based systems engineering approach at Claas. Hope to see you again as a follower of systems engineering. Thanks for joining.
All right, gentlemen, thank you for this very structured overview of what you do and how it all works. Ladies and gentlemen, before we jump into our Q&A session, I would like to clear the stage for your feature presentation. Maik, and Kai is afterwards, I think, right?
Yes.
All right, then the stage is yours. Thank you.
Thank you. Yes, to put all that a little bit more in context, why these companies believe we have something special, created something special. So first of all, when you look at the Dassault Systèmes, what made us special, as mentioned, is the purpose. We both share the same values and the purpose. We, as Dassault Systèmes, we have a really strong purpose harmonizing product natures in life. You probably all have seen that already on some ads somewhere. But this really drives us and drives our values. Secondly, we've grown up to 20,000 people globally. We have 3 headquarters. Main headquarters in Paris, but we're actually also as well ourselves leveraging the platform to develop our software and to trace our software back and forth. 12,600 partners, long-term driven, majority still with the owners, the Dassault family, and we are very proud of our huge amount of customers. However, when you look to Dassault Systèmes, how they grew up, starting in '81 with CATIA V3 on mainframes and Unix machines, then the theme of CAD and PLM got stuck in the 2000s, and this is exactly where we, with the 3D experience, then created for us the path to grow, and already at this time thought about how can a system of a company work together. And in 2012-13, we created the 3D experience as a technology stack, which helped us growing further from the manufacturing-dominated industries into process industries, and nowadays we even serve the pharma industry with the latest acquisition last year of Medidata. The aim of Dassault Systèmes is really taking PLM and experiences into the systems of systems, and as part of that, humans are also part of system. However, the 3D experience came to the right moment, since we've been at the very middle. We're piled up in silos, and for us, 3D experience was not only a great technology, it was also a lever to transform the organization, defining a common dictionary for each other, having interfaces standardized internally already to ease customers to leverage these interfaces for the outside. And in addition, what helped us a lot with this is to share synergies among the industry customers. And one of these synergies, for example, is systems engineering, leveraged a lot in aerospace defense at the very beginning, then automotive, and nowadays it's industrial equipment and many, many others, leveraging this technology. And by that, handing over to Kai.
Yeah, hello. Back again. I also have some context information to give you more insight or more comprehension about systems engineering at Claas. So maybe you can skip over to the next slide. Thanks a lot. So we are very similar to many old-fashioned, established manufacturing companies here in Germany. So our beginning was, of course, our physical product. So, for instance, here you can see our harvester, our premium harvester, the Dominator 106. A long time ago, everything was realized in the end by mechanical solutions with Bowden cables, shafts, etc. If you look on the right-hand side, everything has changed, like in the automotive industry or many other industries. So we're now talking about smart connected products, and we are even no longer talking about drivers of these tractors or harvesters. So we are more talking about pilots, since it's more comparable to an aircraft than to a simple car. But this is of course still the core business of Claas. But if we look in the present, and especially more in the future, it's not only about products. It's about farm equipment systems and farm management systems. What does that mean? So our business now has spread beyond our products. So we need to connect with our competitors like John Deere, like Case, like New Holland, since a farmer normally not only has Claas products on his farm, so he has a very heterogeneous equipment on his farm. So we need to connect these machines. And this is one topic we're really intensely working to interchange telematic data and to have really an efficient logistics chain in the end, and not only the harvesting processes to be optimized. On the right-hand side, on top of that, especially the EU legislation, but also the customer wants to know more about the food he's eating, about the cattle in the background. And so the farmer is urged to really manage and to bring transparency in his entire farm management. And so here also Claas provides solutions. In the end, Maik? In the end, we're doing this with roughly 11,000 people distributed, of course, around the world, with engineering locations in China, in India, in France, in US, in Russia, etc. So we need to find a way how this engineering can be efficient and effectively in the same time. So for this reason, we set up the engineering framework. So if you click on, Maik, if you click on, you see a quite technical slide. I'm sorry for that, but I'm also an engineer. So what you see here on this slide is on the horizontal axis, you see the time or the product life cycle. On the third dimension of that axis, you see our products again. Of course, we as the tool guys or method guides are still serving our engineers and our products. So this is our core business where we create value. On the front layer, you see these three frameworks. So the engineering framework, the customer framework, and the execution framework. So we decided here at Claas to really have these three backbone or these three main frameworks for you to have a better idea what does it mean. So the lowest framework, of course, is our SAP backbone. So the middle customer framework is our Salesforce backbone, and the top is our 3D Experience and Microsoft backbone, where we develop software, hydraulics, mechanical. So the main message here is that we not only focus on product development. So we have a cross-functional view on everything, and me and my team, we are entirely responsible for our engineering framework and providing processes, methods, and tools for our thousands of engineers around the globe. If you zoom into this engineering framework, and then I really like to repeat what Maik said a few minutes ago, it's not about processes, methods, and tools, it's a socio-technical system. So in the end, the human being stands in the middle, and together with the human being, we'd like to realize engineering excellence. And here we have the productive system, so we call that our workplace. As you have seen, our engineering system is that what the engineer finds in his daily work when he logs on or when he starts his machine. So, and below we have these two kind of enablers. So we have, of course, our training and teaching center that's called the Engineering Academy, and we have our engineering labs, and that's what you've recently seen with our systems engineering solution lab. So we do not only have the systems engineering solution lab, we have different labs here at Claas to really look into the future and define together with our strategic partners the future and the future engineering system. So as presented a few minutes ago, so this is our systems engineering solution lab, where we have the mission to define the way how we engineer products in 2025, and not being evolutional. Being revolutionary and being more or less disruptive. Of course, also always in the stake of the user, of the engineers. So to bring a highly usable but also efficient holistic system to our Claas engineering.
Okay, thank you, Kai.
Thank you so much, Kai and Maik, for your presentation. And we have received a number of questions from our viewers, so thank you for that. I'm just going to start out with the first one, which is also a compliment. Great presentation, Sven says. What is the biggest obstacle when it comes to deployment and rollout of SE? That would probably be one for Kai. And here we go, we have it on the large screen as well. Kai, are you still with us?
Yes, I'm still with you.
All right.
The biggest obstacle, there are many obstacles, but two definitely come to my mind very spontaneously. There's the one that we have, of course, very high performant engineers that have been with Claas for over 20, 30 years. These guys grew up with a mechanical product and they have everything in their mind, at least for their profession and to have these people, to have the buy-in of these people, to convince them to really write their knowledge down, to model their knowledge, and to connect their knowledge with other models, or not with other humans, but more or less with other models. This is really a big challenge. This buy-in of the well-experienced people at Claas. And then there's also the other point. This is like in many other companies, the middle management, where we really always have the fight between the operative or the operational projects. So where we really develop our products, and in comparison, we have these process methods and tools. And in the end, the capacity of our people is always 100%. And so we need to fight every day for capacity to really push also these methodologies forward.
Mike, you are nodding vigorously. Would you like to add anything to that?
No, that's exactly hit the point, I think. You need to convince people to do a transformation, because usually everyone is kind of cozy in his environment, doesn't want, this is a human behavior. And with systems engineering, we're crossing or breaking these silos and this personal environment and creating something new for the better for the whole company, not optimizing one silo, optimizing the whole company throughput, which is sometimes difficult to knock into several people's mind.
I can imagine.
Yeah.
Hard task. If we remain in this field, or we take the follow-up question, so to speak, from Akin, will the SE Lab be made available in the 3DS platform in the future? Can you even answer that today?
Yes, made available in...
Mike or Kai?
If I understand the question correctly,
Yes.
I would say the Claas Systems Engineering Lab won't be available, but all the functionality we used is out of the box. So Mike, maybe you can give a comment on that, but you simply can call Mike and ask, and you can do it by yourself. Just do it.
And to add, yes, and if you want to experience, there's the easiest way would be to jump on the cloud. So we offer most of the solution already as software as a service on our cloud. So within 2-3 hours you get access, and test and try. I can only encourage you.
Thank you for that. We're almost out of time. Let's take one last question from Rainer. What did encourage you in the Claas leadership team to transform your engineering approach towards MBSE? Kai, would you like to take this one?
Yes. Maybe as mentioned before. So I see several drivers. One big driver, of course, is the complexity of our machines. But they also driver from the intern that we have many methods and tools that are really not interlinked. And we also have this collaboration among the entire globe. We have software, we have electronics. So there are many drivers. There's not one single driver. And we made an analysis roughly 3-4 years ago. And we said, okay, systems engineering or model-based systems engineering for us seemed to be the dominant approach, where we think, okay, most of the challenges should be addressed with that. And so far, we're on the right way. So there are many obstacles, of course, and many challenges, but so far, we think this is the right way. And we now need to bring this approach by having pilots, by having people involved to bring this to our organization.
Kai, thank you so much for that. If there's nothing you would like to add, Mike, then I would like to thank you. Thank you so much. Good closing words, Kai. Thank you for joining us, and all the best in the future. Keep up the fantastic teamwork. It's been a pleasure.
Thanks for joining.
Thank you, gentlemen. Take care. All right, so maybe we can get a little team applause in the background for our first speakers of the day. This is exciting.